Hello everyone, I hope everybody is fine and doing okay. We're going to continue our lectures in chapter 4. This is section 4.2. We talk about quadratic relations of the form y equals ax squared plus k. A and k are just real numbers. In the past lecture, if you recall, we graphed y equals x squared. We said that if you select different x values, such as -1, -3, -2, 0, 1, 2, 3, few negative, few positive numbers, and you plug in for x and you calculate the value of y, you would end up with the y coordinates of the points on the graph. So -3 squared, it was 9, and then -2 squared is 4, -1 squared is 1, 0, 4, 0, 1, and then 4 and 9. So these are the y coordinates of the points that we calculate after we select arbitrary values for x. By substituting for x, we calculate the values of y. We did this last lecture. And we did draw the graph of the parabola. You see, I already did it here to save time. This is the parabola y equals x squared. We call this the parent function or the basic parabola. So this is actually the parent relation, sometimes known as function as well, parent relation or original basic, let's say, parabola, okay? And we noticed that the vertex, which was the lowest point on the parabola, was located at 0, 0 at the origin. Now, in this lecture, we want to investigate what is going to happen if there is a number, there is a coefficient like 2 in front of x squared. Maybe we have 2x squared, 3x squared, or 10x squared, or sometimes this number could be a negative number, sometimes could be a number less than 1, sometimes more than 1. Basically, that's the value of a here. We want to investigate the role of a when a number like 2 is multiplied by x squared. What happens to the graph of the parabola? That's what we want to investigate here. So I've selected the same x values as before. Now, you see that in order to calculate the value of y, all the numbers we have before, 9, 4, 1, 0, are going to be still, valid, but they have to be multiplied by 2 because of the existence of these 2 in front of x squared. So if I had a -3 squared before, which was 9, now because of this 2, I have to multiply that 9 by 2, and I get 18 instead. If I had 4 before, now because of that 2, I have to multiply 2 by 4. Because 2 times -2 all squared is 2 times 4, which is actually 8. So similarly, every single y coordinate I have before, I have to multiply by 2. So 1 times 2 is 2, 2 times 0 is 0, 2 times 1 is 2, 8, and 18, as you see. So now what we should do, we have to plot these points to see how the graph of this relation y equals 2x squared looks like. So in order to do this, we have the table of values. I'm going to start with 0, 0, and then we have 1 and 2, which is right here, and then we have 2 and 8, I believe. So 2 and 8, and then we have 3 and 18, which would be somewhere up there, and then we're going to have -1 and 2, -2 and 8, and -3 and, again, 18, which is up there. You can draw these graphs on a graph paper, meticulously using paper and pencil, okay? So now the vertex is still at 0, 0, so I'm going to draw a smooth curve passing through these points, and as I said, with a graph paper and pencil, you can do a much better job than me, because I don't have a graph paper here. So when you draw a smooth curve passing through these points, you end up with a parabola like this, the blue one. So y equals 2x squared. I label the graph. Okay, so when you look at this new parabola, whose equation is 2x squared, you see that the vertex did not change. The vertex is still at 0, 0. So I may write down here 0, 0, because the vertex didn't change. But then every other point on the green parabola has a y coordinate which is double the y coordinate of the point on the basic parabola. So we had a y coordinate of 1 before, now we have a 2. We had a y coordinate of 4, now we have an 8. So everything is doubled. And as a result, you see that this blue curve, this blue parabola, is sort of vertically stretched by a factor of 2, we say. So I'm going to call this this transformation that has happened here. I'm going to call this vertical stretch, or you can use expansion, the word expansion, vertical stretch by a factor of 2. That's what has happened here. This is a way that the graph of the original parabola has changed its shape. The graph has become vertically expanded, all right? The vertex, though, didn't change its location. This next parabola, y equals x squared plus 3, there is no number in front of x squared. I mean, the number is 1. So a is equal to 1, just like the basic parabola. But then we have plus 3, which is that k value in this case. So how would this graph look like? We want to investigate in this next exercise. We see that x squared is the same x squared we had before, but we just have plus 3. So what I'm going to do, I'm going to grab all those former y values I had, and I'm going to quickly add 3 to them. So 9 plus 3 is 12. So that's the answer here. 4 plus 3 is 7. 1 plus 3 is going to be 4. 0 plus 3 is going to be 3, and so on and so forth. I fit in the column for the y. And now I just have to plot these new points for this new parabola, y equals x squared plus 3, to investigate to see what happens to a quadratic relation when you add a number such as 3 with x squared. Okay, so plotting the points, 0, 3, I start from here, 0, 3, and then we have 1 and 4. 1 and 4 is right there, negative 1 and 4. I have 2 and 7, so 2 and 7 would be somewhere here, 2 and 7, so that's negative 2 and 7 as well. So as I said, on a graph paper, you can do a much better job. 3 and 12, 3 and 12 is right here. Negative 3 and 12 is also here. So when I'm drawing this parabola to the best of my ability without the graph paper, I end up with this sort of beautiful red parabola. And I'm going to label it y equals x squared plus 3. Okay? So you see that this time the vertex is vertically shifted or translated up by 3 units. The vertex was originally at 0, 0, the origin, but now it's not there anymore. It's gone up basically 3 units. So I'm going to say the vertex is actually 0, 3. And what we say here, we say that the parabola, the green parabola, the parent parabola, the basic parabola, has been vertically shifted up by 3 units. So I'm going to write down here vertical shift, or you may say translation, vertical shift up by 4 units. There's not enough room here, but I think you can see I read it for you. Vertical shift or translation up by 4 units, and that's what happened to the red graph. So if I want to write the vertex, I already did. That's 0, 3. The last one says negative x squared plus 4. This time, the value of a is negative, actually negative 1. Okay, and the value of k is 4. So in this case, when I'm plugging in negative 3 for x, I square it, I get 9. But then because of that negative sign in front, it becomes negative 9. And then when I add it with 4, I end up with negative 9 plus 4, which is negative 5. So I get negative 5 here. When I plug in negative 2 and I square it, I get positive 4. The negative in front causes it to become negative 4. Added with 4, you end up with 0 actually. Plug in negative 1, square it, that will be 1. With the minus in front, becomes negative 1 plus 4, that is, of course, a 3. If you plug in 0, you get a 4, and then you get 3 if x is 1, clearly. If x is 2, you end up with 0 again, and negative 5. So we end up with a new series of points, and we have to, of course, plot them. I'm going to start with 0, 4, which is right here. And then I have 1 and 3. 1 and 3 is here. Negative 1 and 3 is here. Then we have 2 and 0, which is right there. Negative 2 and 0 is here. And then 3 and negative 5. 1, 2, 3, 4, 5. So that's negative 5 right there, and that's 3. And then negative 3 and negative 5. So it would be a parabola that looks like this. You see that? This time we notice that the parabola opens downwards. So I label it y equals negative x squared plus 4. The vertex is located at 0, 4 this time. And about the equation of axis of symmetry for the green parabola, it was of course x equals 0, which is the equation of y-axis clearly. When we vertically stretched the parabola, we ended up with the blue one. It didn't affect the vertical axis of symmetry, so the equation is the same. But when we shifted it vertically up and we got the red parabola, again, you see that the axis of symmetry didn't change, so still the equation is the same as x equals 0. And even if when the parabola was opening downwards and it was vertically shifted up by 4 units, still the axis of symmetry, which is that vertical line cutting the parabola in half, did not change its position. So the equation is the same for all of them. Direction of opening for the first one was up, next one is up, this was up, but the last one, because of the value of a, which was a negative number, it was down. Optimal value is actually the y-coordinate of the vertex. So basically this k is called the optimal value. Now what does that mean? Optimal value is actually maximum or minimum value. If the parabola opens upwards, we have a minimum point, the vertex is a minimum, therefore that k is called the minimum value. But if the parabola opens downwards, then the value of k would be called the maximum value, okay? Maximum, minimum values, generally speaking, are known as optimal values. So for the first green parabola, the y-coordinate of the vertex was 0, so I'll say the optimal value was 0. In fact, it was a minimum value, to be specific. For the second parabola, the blue one, optimal value was still 0. It was, again, a mean value. For the third parabola, the red one, the minimum value this time was actually 3, because the y-coordinate of the vertex, or that so-called k value, was 3. And for the last one, because the parabola was opening downwards, the vertex was a maximum point, and we did have a max value instead of mean value. And in this case, the max value was 4, clearly because the y-coordinate of the vertex was 4. So this, I think, lecture gives you enough information about the transformations involved with parabolas. And I think I forgot the last one. For the last one, when you want to mention the transformations, you're going to say we have a reflection in the x-axis with a vertical shift up 4 units. So reflection in the x-axis because of the negative sign, and then vertical shift up 4 units. 2 transformations are involved for the last parabola I graphed. Please watch this lecture several times, not only once. I repeat several times, and try to redo them, try to draw these graphs on a graph paper and take notes so that you can learn these better and better. Practice using the textbook questions, and hopefully you will be fine. Thank you.